All right, so learning target 10 says we are going to take a graph of a hyperbola and write an equation. Learning target 11 says we're going to take a list of information and write an equation. So all we're doing today is writing equations. So what are the 4 things you need to know in order to write an equation?
A and B. Center, plot B.
Center, A and B, those are good. I need one more thing.
Vertex. No.
You're going to just write the equation. You don't have to have the asymptotes.
Oh, you need to know the thing that goes underneath the divide line. It's horizontal.
You need the orientation. You need to know if it's horizontal or vertical. If you have those 4 things, then you can write an equation. And so it applies to both learning target 10 and 11 then. So when you're looking at a graph, this first one, we're just writing an equation for this graph. We know what orientation it is. Is it horizontal or vertical? Right, because it's the branches are opening vertically. We got that. No big deal. It tells us the center. We don't have to figure it out. It tells us the center. So that's nice. So they're just going to figure out A and B, which I can do from the graph if you know what A and B are. If you don't know the definitions of what A and B represent, then you can't figure them out. And that's the problem we ran into with ellipses. So for A is the distance from the center to a vertex. So how far is it from the center to a vertex? 6. 1, 2, 3, 4, 5, 6. So A is 6. Now, with an ellipse, you had 2 sets of vertices. So you had an easy way to find B. In this case, the second axis is imaginary, and so it's not as easy. They include, in this picture, they have included this box, which I know it's hard to see in your notes. But I need to show you how to make that box anyway, because if you didn't have the box, you need to be able to make the box so you can find what B is. Okay? So if you start at a vertex, and you draw a line until you hit an asymptote in both directions, for both vertices, then you can connect, and you have this rectangle shape. The conjugate axis, that imaginary axis, it goes through the center and stops at the edges of that rectangle. Okay? So B is the center to the edge of that rectangle, instead of being from the center to a minor vertex like it was with ellipses. So what is B? What's the distance there? 5. All right, so if we're going to write the equation, since it's vertical, y goes first. So I have, again, the center is 2, -4, so that's hk. So you have y plus 4 squared, x minus 2 squared, and then a squared always goes first. So you have 6 squared, which is 36, and 5 squared, which is 25. Questions about that one? Then do the second one. I think you can handle it. So you have to count a little bit. It's okay. It is. It says it. It has an O next to it. You don't have to count out loud. Well, I wouldn't. The correct equation is on the board if you want to check your answer. Mm-hmm. A is from the center to a vertex. All right, any questions about that example? Anyone at all? Everyone knows why it's horizontal? Hopefully you got the center right. Everyone knows why it's A and B.
This is the same thing with rectangle.
But it's a hyperbola instead of an ellipse. Yes.
We're not gonna have like a few
No, we're going to test over circles and ellipses. So we're going to have a test over hyperbolas and parabolas. But there's not a big test at the end. That's what he asked about. But the last two learning targets, 14 and 15, are about systems of equations and inequalities of conic sections. So then they all will be mixed together. Systems of equations and inequalities involving conic sections. All of these things we've been doing. Circles, ellipses, hyperbolas, and parabolas. Okay. Any questions about learning target 10? Learning target 11, then. We're still writing equations. This time we're writing equations based on information that's given to us. So I'm going to remind you some vocabulary I talked about with learning target 9, and then we'll answer some questions. So a hyperbola has two axes of symmetry. So in an ellipse, we call them the major and minor axis, but that's not what they're called here. So the line segment connecting the vertices is called the transverse axis and has a length of 2a units. The transverse axis is like the major axis if you're talking about ellipses. And so from the center to a vertex is A, so the whole thing would be 2a. That imaginary axis that we drew in earlier when we drew the rectangle, that's called the conjugate axis. It's perpendicular to the transverse axis, and it has a length of 2b units, because from the center to the side of that rectangle is b. So again, when we're writing equations, you still need to know those four things: orientation, A, B, and the center. So the first one is very straightforward. It tells you everything you need to know. So the center is at 1, -4. A is 5, B is 2, and it has a horizontal transverse axis. Since the transverse axis is like the major axis, then I know it's horizontal. So it tells me that. So I should be able to just write the equation in number 10. They give you all of the information you would need. So if x minus 1 squared minus y plus 4 squared, a is 5, so a squared is 25, b is 2, so b squared is 4. Questions about that? Plugging everything into the equation. Mm-hmm. Yes. All right. On the second one, on my screen on number 11, and yours is just, I think, B. The length of the conjugate axis is 6 units. What can I do with that information? Divide by 2, and that will give me what? Right. So B is 3. It says the vertices are at 3, 4, and 3, 0. So if you need to, you can draw a quick little sketch. The vertices are on the major axis or the transverse axis. So is this horizontal or vertical?
Vertical.
Vertical. The center is in between the vertices. So what's the center going to be? 3, 2. And then we can figure out A, because A is the distance from the center to a vertex. We talked about this yesterday. A does not have to be bigger than B anymore. So it's completely acceptable that A is 2 and B is 3. All right. Any questions about where any of that information came from? A is from the distance from the center to a vertex. So from the center to a vertex. They told it to us already. All right, so we're going to write out the equation. So we have vertical, so y comes first, minus 2. Make sure you put those in the right order. A squared always comes first, so 4, and then 9, because 2 squared and 3 squared. And A and B have nothing to do with whether it's horizontal or vertical anymore. questions on those two examples? All right. Next one. You need to know another vocabulary word. In the standard form of the equation of a hyperbola, if A equals B, then it's equilateral. Right? With ellipses and circles, if you had A and B equal, then you had a circle instead of an ellipse, right? Here, that rectangle we had earlier becomes a square, but it still matters which comes first, X or Y, to figure out if it's horizontal or vertical, because the branches of the hyperbola have to go somewhere, right? Okay, so with the example, the hyperbola is equilateral, so I know A equals B. I'm going to use that to my advantage in a second. And it has foci at 0, 6, and 0, negative 6. So again, we can graph these. 0, 6, 0, negative 6. The foci are on the transverse axis. They're on the same axis as the vertices. So is this vertical or horizontal?
Vertical.
Just like the center is in the middle of the vertices, the center is also in the middle of the foci. So what's the center? C is the distance from the center to a focus. So what is C? Okay, so I know it's vertical, I know the center, and I know C is 6, all from knowing about the foci. And so now I'm done with those. I can get no more information from that. Now, I have to have A and B still. I have that equation C squared equals A squared plus B squared. That exists. I know that 36 equals A squared plus B squared because C was 6.
6 equals 6. 18.
So we know A equals B. So since A equals B, I have two unknowns, and I can't solve for both unknowns. But if A equals B, I can change one of those unknowns because they're both the same. So I can change this to 36 equals A squared plus A squared. Because A and B are the same. You could change it to B squared plus B squared. It doesn't matter. But now I only have one variable. So I have 36 equals 2A squared. And so I get 18 equals A squared. Questions about what I just did? If A and B are the same, then B squared is also 18. You can find the square roots if you want to, but in the equation we need A squared and B squared. So you just square them again in a second. All right. So it's vertical. So you have Y squared first. And then I have 18 and 18. If I gave you this equation and not the other way around, you'd be able to tell me it's vertical. Because Y came first.
Y came first. Yeah.
All right. Questions about that example?
Nope.
All right, one more. Like an ellipse, the shape of a hyperbola is determined by its eccentricity. So E equals C over A is still the formula. It has not changed. That's still important. That is the most important thing on this page. We can talk about how E changes the look of the graph, but the equation is what we need to write the actual equations. If E is close to 1, you have wider branches. E is not close to 1, you have narrower branches. Again, that's the whole point, but in order to write an equation like we're doing in Learning Target 11, we just need to know that E equals C over A. That hasn't changed. All right. The eccentricity of the hyperbola is 5 over 3. So I just said E equals C over A, and I know that 5 over 3 is E. So I'm going to be able to use that in a second. It says the foci are at 10, 0 and negative 10, 0. So then if you draw a graph, 10, 0, negative 10, 0, it's horizontal. The center is 0, 0. And what else can I get from the foci? C, and so C is 10. Okay, so now if I go back over here, I know C is 10, so I have 5 over 3 equals 10 over A. Either you're good at ratios, and you can tell me what this is right now, or you need to cross multiply it and solve for A. So A is 6. So I have the orientation, I have the center, I have A, I don't have B, but I do have C. So how am I going to find B?
You do C squared equals A squared.
Correct. So you have 100 because C is 10, and 36 because A is 6. So if you subtract, you get 64. You can take the square root and get 8, but you're going to square it again in a second in the equation. So this is horizontal, so you have x first, so x squared minus y squared. 36, because a squared is always first. No. No, it just happened to be like that. You always can cross multiply and solve. So 5a equals 30, so a equals 6. Questions?